Space isn't just the final frontier. It might be the next gold rush. Asteroids, moons, and even planets are loaded with precious resources. But how does space mining actually work? What technology is needed? Who owns space? And is it really worth it? In this episode of Astrotech Universe, we're digging deep into the future of space mining, one of the boldest ventures humanity has ever considered. Why mine in space? Our planet has limited resources, especially rare Earth elements used in electronics, batteries, and clean energy tech. Meanwhile, space is full of raw materials: asteroids rich in platinum, nickel, and cobalt, moon regolith containing helium-3 for fusion, Mars with potential for iron, water ice, and aluminum. The estimated value of a single metal-rich asteroid: trillions of dollars. What can we mine? Here's what space miners are after: water ice for fuel, hydrogen and oxygen, and life support; platinum group metals for electronics, aerospace, and medicine; iron, nickel, cobalt for construction in orbit; helium-3, potential clean fusion energy source from the moon. Asteroids are classified into types, CSM types, each with different compositions. Where will mining happen? The three primary mining zones will be near-Earth asteroids, NEAs, easier to reach with low fuel cost; the moon, close, with ice at the poles and helium-3 deposits; the asteroid belt, long-term goal, immense resource potential. Robotic probes will scout locations, then automated mining units will be sent. How will we mine in space? Space mining will rely heavily on automation. Key technologies include robotic drills for breaking asteroid surface, microgravity excavators to handle loose material, 3D mapping drones to survey terrain, USRU systems, in situ resource utilization to refine materials on site. Instead of sending everything back to Earth, the focus may shift to using resources in space to build stations or fuel missions. Challenges of space mining. Mining in space is extremely difficult. Microgravity makes excavation unpredictable. Radiation and extreme temperatures damage equipment. Communication delays make real-time control hard. Launch costs and energy supply remain major barriers. Every part of the system must be fail-safe and durable, or missions could be lost. Who owns space resources? The Outer Space Treaty of 1967 says no nation can own space, but it doesn't clearly address private mining rights. Newer laws like the U.S. Commercial Space Launch Competitiveness Act, 2015, and similar ones in Luxembourg support resource ownership. Still, global legal frameworks are murky, and future space mining could trigger economic and political conflicts. Companies leading the way. Several companies and agencies are investing in space mining. NASA, testing ISRU tech on Artemis lunar missions; SpaceX, making transport to space cheaper and reusable; Planetary Resources and Deep Space Industries, early asteroid mining startups; Blue Origin, long-term lunar base concepts. These pioneers are laying the foundation for a space-based economy. Space mining and Earth's future. Space mining could dramatically change life on Earth, reduce strain on Earth's ecosystems, provide clean energy from helium-3, enable construction of massive space habitats, fund deeper exploration missions to Mars and beyond. But it could also increase inequality if only a few players control the resources. When will it happen? Some early missions may launch in the 2030s. NASA's Artemis program will test lunar ISRU soon. Robotic asteroid mining is expected within a few decades, depending on tech and funding. Mass-scale mining may take until the second half of the 21st century, but it's coming, piece by piece. Space mining sounds like science fiction, but the science is real. The resources are out there, and the race has already begun. Who will own the stars? Who will shape the next era of civilization? Thanks for watching Astrotech Universe. Subscribe for more cosmic documentaries and tell us in the comments: should we mine space or leave it untouched?